Today is my presentation about Mirai Botnet. So I believe Dr. Silva yesterday talked briefly about Mirai Botnet, and in today's presentation we'll talk in details about Mirai Botnet. And at the end of this presentation, we will have hands-on on how to analyze the Mirai Botnet using using the benchmark dataset. Okay. So first, when we talk about Mirai Botnet, okay, we should talk about the IoT because the Mirai botnet is tied to Internet of Things. So when we search on the internet about the definitions of IoT, there are many definitions for IoT. Okay, for example, here, Grantor, which is a leading research company, define Internet of Things as a network of physical objects that contain embedded technology to communicate and sense or interact with their internal states and external environment. Okay, so another definition by Wikipedia is describe the network of physical objects or things that are embedded within the sensor software and other technological for the purpose of connecting and exchange data with other devices. And finally, another definition by Cisco. So it defines the Internet of Things as an intelligent connectivity of physical devices, driving a massive gain in efficiency, business growth, and the quality of life. But in general, if you will talk about the definition of IoT, so simply it's how to turn any physical object, okay? So this is a physical object can be surrounding us, or any physical object that we want to turn it to the think or smart object. To do so, the physical objects must be equipped with three things. The first thing is sensor. The second one is unique identification. And the third one, connectivity. So when we're talking about sensor here, sensor or sensors, that means we need to sense or collect the data, send this data to intermediate nodes, and this intermediate nodes send it to the gateway, and from the gateway, it will push the collected data to the cloud. So the decision maker can access this data and utilize it to take a right, for example, right decision. Okay. So, and also since maybe the device can collect the data and send it straight or direct to the gateway, and from gateway to the cloud without need to send it to any intermediate nodes. So the second thing is unique identifications, and here all the nodes or tiny devices of IoT must equipped with a unique identification, which is basically maybe it's an IPv4 or an IPv6. And since IPv4 is exhausted, the address pool of IPv4 is exhausted, so we can find a lot of IoT devices are equipped with IPv6. So this identification must be unique in the IoT networks. So the last thing is connectivity. And here, IoT devices using different communications protocol stack, which is different from the protocol stack that are equipped with conventional devices such as our laptops or PC. Example of the communication protocols used by IoT, for example, is like Zigbee protocol or 6LoWPAN or LoRa. So this is the protocol, communication protocol, has the capability to work on the tiny devices, and these tiny devices has a low constraint resource in term of the RAM or in term of the microprocessor. So this is the definitions of the IoT. So next, when we see the number of devices or a number of IoT devices connected to the internet, we can see there is a exponential increment in the number of devices connecting to the internet. So like, for example, by 2025, the number of connecting devices and number of connecting IoT devices to the internet will be 75 billion devices. Okay, so what is the relations between the number of connecting devices and Mirai botnet or any Mirai variant? So Mirai and other malicious code usually used to carry out different type of attacks. One of the common or efficient attack be used by these malicious codes are DDoS attacks. And we will talk about DDoS attack and those attack later in the slides, but the efficiency of DDoS attacks, it depends on the involvement of the compromised node to carry out this attack. So more nodes we have in to carry out these DDoS attacks, the attack will be more efficient and it will be more destructive. So with this huge number of connecting devices, 75 billion in the internet, so they may expose to the different type of the vulnerabilities. So for example, if let's say a very minimum portion of this like devices got infected, so and this infected device used or instructed to carry out of DDoS attack, so the impact of this attack will be destructive. So that's why the DDoS attack that triggered from IoT devices is more destructive compared to the conventional compromised nodes, because in the conventional nodes, compromised nodes, the numbers will be less compared to the connected device, IoT connected device. Okay, so what is the IoT botnet? So in conventional botnet, we have bot and we have CNC server and we have also bot master. So this bot, or it's a compromised node. So it can be your PC or laptop or any other device other than the tiny device or IT device. So this bot are compromised and it's communicate with CNC server and CNC server communicate with a bot master, okay, to be instructed to carry out certain type of the attacks. Okay. So this is the conventional botnets. But in IoT, like late on December 2003, there is one researcher, his name David Knight, and he's worked in a Proofprint company, which is a research-based company in US. So he noticed there is hundreds of thousands of email logged at the gateway. So when he traced the source of this email, he found out that the source has come out from tiny devices, or it's unusual. It's not triggered from, let's say, conventional devices. It's triggered from, like, for example, smart TV, or it's triggered from, let's say, baby monitoring device. So this is weird because most of the attacks triggered from from visual devices, from laptop, PC, or certain servers. So after that, he identified that these devices who compromised, this tiny device or IT devices compromised, he named it ThinkBot. Okay, so in the previous slide, when the nodes is compromised by botnet, we can name it as a bot or zombie. But when the IoT device infected by a malicious code, it's called ThinkBot. Okay, so ThinkBot also operate same as a conventional device, but the only difference is the involvement of the IoT devices, okay, in the malicious activity. Okay, and this is very dangerous because, as we mentioned earlier, this number of IoT devices that connecting to the internet, it's much higher compared to the conventional devices. Because maybe in our home, like, we have a lot of IoT devices, like maybe you have 3, 4, 5, compared to our conventional devices like laptop or PC. So impact of these attacks will be huge and destructive. Okay, so here in this slides, we want to talk about who's attacking whom. And these tools use real-time attack trackers. So every day we hear that there are certain attacks triggered from X country against Y country, and it's attacking certain devices. So in the following 3 slides, we will talk about 3 websites that use for real-time attack trackers. Okay, so the first website, FireEye, it's okay. So I'm connecting. Okay, so this is lifetime or real life is to show you who's attacking who. So for example, here we can find different countries, okay, attacking on different, okay, country, and here we can find the, okay, so it's need a time so you can more details about the attacks also, and about the service. Here we have top 5 reported industries that infected by the attacks are financials, and telecom, manufacturing, and insurance. Okay, so attack today also we have, as for now, we have 281,000 attack. Okay, so and this is, you know, it's real life show you what are the attackings, name of the attacks now. So this is a very simple website to show you attack tracker, and it's live. So okay, another website also is, okay, so this is another website. Okay, it has the same functionality of the former one. Okay, so it's maybe what clearly give you the attack and the severity of the each attack. So the severity of the attacks ranges from medium, high, and low, and the location of the attacks. Okay, so again, here we can see the source of attack, destinations, and also we find out the attacks. Okay, so the third one is a little bit more comprehensive. Okay, Net Scout. So this one gives you the some features, or the features that you can filter the traffic, or the visualized data based on predefined filters. For example, if you want to filter based on countries, we can select the country from here. Okay, so for example, we have, okay, from here, so it's already listed. So all of the attacks that are sources or triggered from United States of America, and also we can define, okay, the industry sectors also. Here also there is a predefined list that also give you, okay, what are the services that you are interested on. So here for informations, we have 47 now. And also you can, okay, the destination country, and also the industry sector. And the last things also, if you are interested to see certain type of attacks, like for example, UDP flooding attack, IP fragmentation, or the attacks related to IPv4, you can also filter out from here. Okay, so this is a bit more comprehensive compared to the two former websites. Okay, another interesting also thing on this website, you can read a summary from here. Okay, so this is a summary of what is happening or what is collecting. Okay, so and it's a historical data. Okay, so all of this data you can study it, and you can see here there is a top source country, and there is a top destinations countries, and we have here US in the top of the list, and for also destination is US in the top of the list. So it's bi-directional. Okay, so this is a summary. Another also here you can, okay, also filter out this report. So threat report also. Okay, you can download a PDF file of this thread report, but you have to sign in or sign up first and download this all graphics. So here, what is interesting here in this report, we wanna see DDoS attack. Okay, read more about DDoS attack. So you see here, most of the data is related to the DDoS attacks. And here where the IoT devices or Mirai botnets used mainly to trigger out different type of DDoS attacks. And we will see later what are type of DDoS attack that used by Mirai botnet. Okay, so you can have close eye on all the data reported in this, okay, report. As I mentioned earlier, you can download it and you can have. So this report are, you know, in the first half of the year and second half of the year, As for now, I think the first half of the year is already out. So I think the second half of this year will be released by end of December. Okay, so this is the three websites is to show you what are the real-time attack trackers using the three websites. So next, why IoT attractive for attackers? Okay, so basically for different reasons. We have insecure web mobile cloud interface, insufficient authentication and authorizations. And maybe this is the second reason is the entry point for Mirai botnet. So when we said authentication and authorization, specifically the authentications. So when we talk about authentication is your credentials, username and password. When we talk about authorizations, that's mean what is the permission that you have after you gain access to the system. Okay, so the most important thing is how to authenticate your username and password. So most of the IoT devices, or let's say most of our, let's say, appliance, home appliance, which is considered as smart or IoT, when users purchase these devices, it leaves the default username and password. Okay, for example, for router, they use the default username and password like admin. Okay, so the attackers here, they can have a predefined list of username and password. This predefined list of username and password is really collected from the default manufacturer username and password. So, and that what they can do brute force attack to guess what is the username and password. And it's worked in most of the cases. And even though the brute force attack is quite outdated and it's old, nothing new, but it's been used by Mirai botnet and also its variant. So to gain access of the IoT devices. So we'll talk about this one more details, and we'll see the hard coded list in the Mirai botnet source code itself. Okay. So the second one is insecure networks, services, unnecessary open network port. And again, when we talk about specifically for Mirai, later on we see that there are certain port, okay, and this is unnecessary port is left open. So the attackers utilize this vulnerability to gain access to the IoT device. For example, if you want to buy buy any devices and the telnet port is open, 23 open. So, but you don't have telnet in access to that device. So why you want to leave it open? So if you don't use it, you have to close it. Otherwise, it may be vulnerable to different type of attacks. And later on, again, we'll see how the Mirai botnet use open port to gain access to the IoT devices. So also lack of transport encryption, integrity verification, insufficient security, all of these, okay, so makes things easy for attackers to attack the IoT devices. Okay, so here in this slide, we can see the IoT attack volume from June 2018 and to May 2020. And we can see there is a exponential increment in the number of IoT attacks. Okay, so compared to 2018 until now 2020. Okay, and the source of this data is IPM security. Okay, so let's talk about Mirai botnet in detail. So we talk about the botnet, and we know that Mirai is targeting the IoT devices. So what is the Mirai botnet? So first is self-propagating malware. When we talk about self-propagating malware, that's mean there is no need for human intervention. Okay. For example, sometimes we have to take an action to activate the malicious code. For example, if you have worm in our pen drive, okay. So when you open your pen drive and you double click on the file, so the code will be activated and start to self-propagate. But here there is no need to have any intervention or any action to make the Mirai botnet activate. So it's self-propagating. There is no need to any action from a human to be activated. So, and it's run and infects smart devices that run on multi-different processors or pre-processor architectures, and turn them into a network of remotely controlled bots or zombies. Okay, and here is a maybe sample of these devices. Okay, CCTV, routers, all are vulnerable to Mirai botnets. So the most important things is once I infect, or once the Mirai botnet infect any device, okay, it will turn to the ThinkBot, and it will be used to carry out different type of attacks, and one of them is DDoS attacks. Okay, so the Mirai botnet could infect poorly protected internet device by using telnet again. So this is a telnet, and this is aligned with, you know, this what we have explained here. Okay, for authentications, and telnet for the network port. Okay, so here for the protected device by using telnet, so it's port 23 to find those that are still using their factory default username and password. And this is why the IoT devices is vulnerable for different type of attack, because simply users are like this, most of the users are not sophisticated users, are naive users, so who are like leave like certain things, like leave their default factory default username and password, they never change it, or they leave open ports, leave it open. So all of these things will contribute to make these devices vulnerable for Mirai botnet. So based on data analysis collected from honeypots, okay, so honeypots is again is a dedicated network that has different type of devices, and this different type of devices is meant to be vulnerable. That's mean these devices, for example, have default manufacturer username and password, has telnet in open. So when the Mirai botnets do scanning and find this device in honeypots, so the researcher will start to collect the traffic of Mirai botnet to study the behavior and the characteristics of this attack. So attack on IoT devices are not usually not sophisticated, and it's true, as I told you. For example, it's based on the brute force attack to guess the username and password. Okay, it's based on the open telnet board to attack the devices. So it's not unsophisticated attacks, and even it's based on the very simple or common type of attacks. So, but it's still like as user might not even notice their device are being exploited. Okay. So the malware family behind 39% of the attacks, and Mirai is capable of using and exploit the meaning that those botnet can clip through old and patch vulnerabilities to the device and control it. Okay, and this is the techniques to gain in the techniques that is mainly used to gain access to the device. So by using brute force attacks. Okay, so here we can see still like that's mean once the device is infected, your IoT device is infected, so the malicious code will be loaded in the memory of the device. So once you restart or reboot the device, the Mirai botnet will be no longer exist. However, it will like takes like a few minutes to be reinfected again. Okay, so once you reboot, the Mirai botnets will be deleted, but once it's up again, the Mirai botnets will like takes like few minutes to reinfect this device again. Okay, so we have a lot of malicious codes out there in the internet. So some of them that are very common, and some of them are not very well known. And to make the malicious code is popular or not, it depends what are the destructive impact that resulted from this malicious code. Okay, for example, we have code red mail war, we have slammer worm. So this is all are very well known when we come to the network security community. And same also Mirai. So Mirai Botnet is very popular for a few reasons. So first thing, I mean, the three main things that makes the Mirai Botnets, okay, based on this timeline, is the services that's targeted by Mirai. So Mirai, it was starting on 1st of August 2016, and the first attack was targeting Crips on security, which is a very popular and famous security blog. Okay, so it's targeting the first one. Okay, and again, it's target DYN DNS provider. So DNS provider, this is a DNS provider is not hosting or provide the servers to very common website. It's host Amazon or give domain name to the Amazon, GitHub, Netflix, and PayPal. So this DNS provider also being attacked or targeting by Mirai botnets. So it was on October 2016. And in the same month, another famous telecom company based in Liberia is also being targeted by this attack. And the impact of this attack is to take out the internet connectivity on the whole country. So after this, after almost, let's say, less than 1 year, the Mirai botnet, the author of Mirai botnet is identified. And before that, the code was posted also online. Okay, so the source code of the, see here in October, the source code released on 30 September 2016. And once the code is released, I can have a lot of Mirai variant malicious code. Okay. We'll see how we can modify this, easily modify this source code, and you can download it in from GitHub also to have a look on the code that's the code behind this Mirai botnet. Okay, so this is 3 victims makes Mirai botnet is very popular, and also the destructive impact of Mirai botnets was huge. And okay, and once it's released, we are no longer, like say, able only to detect Mirai botnet, but we have also have to look to other Mirai variants. We have to study other behavior or characteristics of malicious code that based on the Mirai botnet. So in 2016, this is the distributions of the infection device. So on the top of the list, we can find Brazil, and at the bottom, we can find Argentina. So we have a lot of infected devices. And this is back on 2016. If you compare the devices, as we showed earlier, the devices is in exponential increment. So in 2016, the number of connecting device is lower compared to connecting device in 2020. So more infected device. Okay, that's mean the destructive of the attacks or the efficiency of, for example, DDoS attack will be stronger. Okay, so this is in 2016. So after collecting the data about Mirai, so they come up with this distribution. The source of this table, again, from this paper. Okay, so how Mirai works. So when we talk about Mirai, the first thing or the first step is to do scanning, or let's say victim discovery. And scanning is not the first step that's used for Mirai. It's a malicious, or it's an activity. So it can be malicious activity or can be normal activity. Network administrators sometimes trigger network scanning to identify the troubleshooting in the network. But things is different when we talk about the malicious activity. If the malicious malicious code. So if malicious code performs scanning, that's mean the malicious code try to identify victims. Okay, so in Mirai, scanning is used to identify the victims that has TCP port 23 or 2323 is open, and this is the port of Telnet. Okay, so once it's identified using scanning, so it will perform brute force dictionary attacks. And here, the attackers has predefined dataset consists of the username and password. So they use the username, the predefined username and password to try to guess what are the username and password of this device. Okay, and here they are used the default manufacturer username and password. So if there is a matching, okay, between the username and password or of that's saved in the predefined datasets and the one that the attacker key in, so the attacker will be able to access the IoT devices. Otherwise, it will generate a lot of error messages such as invalid login. So this message can be used as a glue to identify the presence of, let's say, brute force attack. Okay, and we will later on see how this message can be identified by studying Mirai dataset. So after I identify there is a telnet open, and after I successfully gain access to the device, so it's time to infect. Okay, so the infection is the process of transferring the malicious code from the attackers to the victim machines. Once it's infected, it will start to behave in the same way that infected by, meaning that the newly infected device will start to do scanning, okay, and start to do brute force attack to identify new victims. So usually this new scanning and brute force attacking will be performed in the neighborhood devices. Okay, so it will search nearby devices and try to identify if there is new victims or not. If there is a victims, so the network will expand and more victim will be involved in the botnet network. Okay, so this figure shows the 7 steps on how Mirai works. So the first step here is to do scanning. So in the scanning, as we mentioned, we are looking for TCP port 23 or 2323 open. Once I identified, I'll have to report to the report server. Report server will dispatch the malicious code to the loader. The loader will load the malicious code in the victim. Okay, so now the victims have the malicious code. Okay, so as I mentioned earlier, the infected IoT device, it can perform different type of attacks. Okay, so now it's waiting for the instruction. What type of attack that you are want to perform? So this command will come from send command. For example, this device trigger out DDoS attack. Okay, for example, TCP send float attack, or let's say log the username or passwords or whatever, or steal sensitive informations, or it depends on the command sent to from attacker. So the command will be sent through the command and control relay, and also the attacks will take place. Okay, and C, this is C, and C is the intermediate point between the think pod and the attackers. Okay, so once it's infected, it will start to perform different malicious activities. Okay, so in Mirai attacks vectors, we have mainly 2 types of attack. The first type is brute force attack, and the second one is DDoS attack. Okay, so brute force attack, as I mentioned earlier, is to gain access to the networks, and it's followed the scanning activity. And as mentioned earlier, it's based on the predefined username and password. And the second one is DDoS attack. Okay, as we can see here in the brute force attack is an attempt to crack username and password to find or find a hidden web page or to find a key used to encrypt a message. And here in Mirai, we wanna guess or crack or username and password for the devices. And this screenshot is from Mirai source code. As you can see, this is the predefined or the dictionary, okay, that is based on default manufacturer username and password. As you can see here, so this is all the codes. Okay, so if we, okay, so here is the source code of Mirai Botnet. Okay, so basically, if I already downloaded, and if you go to scanner.c, and if you scroll down, you will find this, okay? So username and password. So when I talk about the Mirai source code is already released, that means there are different type of attacks that based on Mirai variant. We call it Mirai variants malicious code. So one of the things that they can do is to increase or have more username and passwords. Okay, so add more username and passwords here. So increase the size of the predefined dataset that consists of username and password. So this is basically from the source code of Mirai. So again, okay, and when we talk about the second type of Mirai botnet, the second attack vector in Mirai botnets is DDoS attack. So when we talk about those, the DDoS attack, it stands for Denial Distributed of Service, and we have DOS attack. So we have DDoS attack and we have DOS attack. So DDoS attacks, here it depends on the difference between DOS and DDoS attacks depends on the number of the sources that involved in this attack. If we have a single source, it's DOS attack and it's targeting a victim. But if you have a multiple sources here, okay, and these multiple sources are compromised, bot, and it's used to trigger out an attacks, so it's DDoS attacks. And it's more efficient compared with those attacks because the amount, the volume of the attacks that generated from multiple source are higher compared to the single source. And this is what I was mentioned earlier in the diagram that it shows the number of connecting device. So imagine that, you know, we have like 50 or 75 billion device connecting to the internet. This is a forecast by 2025. So like imagine like 10% of this device will be infected or compromised. So this, the left side will be increased. So if the left side that's mean increased, that means the number of think bot will be increased, and the number of the amount of the traffic will also be increased. Okay, so the impact on the victim will be high. So if all the packets sent to the victims will not have the ability to handle all unnecessary traffic sent or purposely sent by the attackers. Okay, because the victim has, let's say, certain resources, limited resources. So if this limited resources, okay, fully saturated by processing unnecessary traffic sent by the attackers, so it will, after a while, it will be unavailable because it will be busy responding to this unnecessary traffic and ignoring all the legitimate traffic sent by normal users. And this is how the DDoS works. The main objective of DDoS attacks is to disturb the availability of the victim. It tries to make it unavailable. Okay, so it's become more severe in the when the DDoS attack triggered from the IoT devices. Okay, and here we can see like the percentage of the attacks and the volume of the attacks generated by the botnet, by the IoT botnets that targeting or that generated from DDoS attacks. Okay, again, since we have the Mirai source code, okay, so we can also see what are the DDoS attacks, okay, that already predefined on the source code. So we can have this 10 types of attacks, okay, used in DDoS attack. So we have TCP sync flooding attack and HTTP flooding attack, TCP acknowledge flooding attacks. And what we are notice here is not like say, it's very common and it's very popular attacks like brute force attack and TCP sync flooding attack. So TCP sync flooding attack is out there since long time ago, but yet it's been using by Mirai, and the impact of these attacks was huge and destructive. Okay, so this is again from the source code, and we'll be analyzing a TCP sync flooding attack using a dataset. And this is again a screenshot from the source code. It's defined these 10 types of attacks. Okay, so we have 4, 3, and 3, 7, 7 types of attack that is defined in the Mirai source code. Again, if you go to the Mirai source codes and we go to the attacker, click on the attackers, and we can scroll here. Okay, scroll. I think it's up there. Okay, so this is the 10 types of attacks that used to trigger DDoS attack. So this already predefined the source code. If, let's say again, how the Mirai variance works, it can add another type of attacks. So in the attack vectors, or as I mentioned earlier, it can increase the dictionary of username and password for the brute force attack. Okay, so this is again from the source code. Okay, so next. Okay, so this is where you can find the Mirai source code. You can download it, but some of the browser will not allow you to, like say, to download this code. So you have to figure it out how to download it from the GitHub. And this is the Mirai adaptation and variance, how the Mirai adaptation and variance. And as I mentioned earlier, there are, let's see, we can see 2 ways. The first one, as I mentioned earlier, is to increase the dictionary of the username and password in brute force attack, or also to increase the number of attacks. You include a new type of attacks. Okay, so we have predefined 10 types of attacks which used to be in DDoS attacks. We can add more new. So this is also another extra way to use Mirai, how Mirai variance works. Also, it can update from IP based to domain based, more username and password pairs as mentioned, and also we can closing the of infection port 20, TCP port 23 and TCP 2323, deletion of executing binary code to hide this code from detections, or to hide the process ID of this code. So it will be difficult to be detected by, let's say, security mechanisms. So again, this is the source code. You can download this source code from the internet. Okay, so this is how to defend against Mirai botnets. And I think I also, like from my talk, you can see that maybe the first one is to change your default username and password, to close unnecessary port for certain services. Like if you don't use Telnet N, close the port 23 or 2323, change your default user and password. Okay, so this is the number one, automatic updates. Of course, you have to make your let's say your device is up to date. Okay, and you have to be patched with the latest security updates. And of course, if mechanism for end of life device, because if we know there's no mechanism or if there is no longer support for your device, that means it will not have the updates for security, specifically for security related issues. So make sure that your device or mechanism is up to date and you patch your devices with the latest security mechanism. Okay, so here we talk about the data sets. Okay, so whenever you propose any mechanism, you want to evaluate it first. So evaluations means you want to see or check whether this mechanism is meeting your expectation or not, whether this mechanism has the ability to detect the presence of the attacks in the network or not. Okay, so the best way is to evaluate this mechanism is to use benchmark datasets. And benchmark datasets actually represent the characteristics and the behaviors of the attacks. So it's carry out on the, for example, in isolated environment. And once we build the isolated environment, we execute this attack and start to log the traffic of these attacks. And later on, we can use these datasets as input to evaluate the mechanisms. So there are a lot of datasets. Actually, these datasets is, we can say, after 2018. Before 2018, there was not much datasets about the IoT. So, and it was a problem that we have like lack of availability for the datasets to evaluate the Mirai botnets. But after 2018, there are a lot of datasets. And in this slide, I'm sharing 3 datasets that can be used to evaluate, okay, to evaluate the any mechanism that, for example, that is designed to detect the Mirai botnet. So we will be focusing on the first one. So first datasets. Okay, so the first datasets you have also, again, if you click, so this is datasets available also for free, and it's in IEEE data board. You have to you have to log into this this website to access, okay, to access the datasets. Okay, so we have here IoT intrusion datasets, and we have a dataset descriptions, which consider as labels for these datasets. So I already downloaded this dataset on my laptop. So it's here. And what this datasets basically is different type of pcap files. Okay, so these pcap files represent different type of attacks that we showed it earlier in our presentation slides. So we have 10 types of DDoS attacks. Like, for example, here we can see sync flooding attack, we have UDP flooding attack, and we have scanning also, which is the first step for Mirai botnet to identify the victims. And we have UDP flooding attacks. So we can study all of these attacks. Okay, so we will be using software just to open the pcap file. This software is called Wireshark. So this is Wireshark. You can search on Google Wireshark and you can download it. So it's open source, okay, and across the platform. That means you can use it in your Windows or in your Mac or your Linux. Okay, so basically this sniffing tool, network protocol analyzer. So it can be run in the live mode, or it can read pickup or historical data. So in our case, we wanna use it to read the offline data, so to analyze what is the pickup file, or whether the pickup file is really reflecting certain type of attack that used by Mirai botnet or not. Okay, so after you download and install it, so we can open the Wireshark here. Okay, as you can see here, we have, let's say, this is the default interface. And if you want to run it in the live mode, we have to select the right network interface card. After selecting the right interface card, we can see that, so we can see that, it's capturing the live traffic. Okay, so this is a permission issue on my Mac, so no worry, but we don't want to use it on the offline mode, on the live mode. We want to use it in offline mode. So for that, we want to study like certain type of attacks. Like as I mentioned earlier, there are TCP sync flooding attack, there is UDP flooding attack, brute force attack, and scam. So this is 4 out of other attacks we will be focusing on analyzing it. Okay, so the first pickup file that we want to work in it is sync flooding attack. So if we open this file, okay, so here we can see that the default, okay, so the default GUI, okay, consists of 4 default like columns. Okay, so these columns, like very helpful like tips is you can, for example, you can add, let's say, a new column here. Okay, for example, if you are talking about TCP sync flooding attack, so I don't want to see the info here. Instead, I want to add a column to see the TCP flags. Okay. Okay, so we can go here and column preferences, and we can go to here columns, and we can add, and we name it, for example, TCP flags. And here we select the, like, for example, custom. And here we type TCP, okay, dot flags dot, for example, SYN, because we are focusing in TCP sync flooding attacks. And we can add here this for maybe informations I don't want to include it, just untick from here. And we can see here is a new column listed here. So to see that the TCP sync is set or not. So that's mean if it's set, that's mean it's using TCP sync flag in TCP protocol. So this is a very good tips to allow you to visualize the traffics. So as you can see that I type a filter like TCP sync, TCP flags dot sync. So this filter is predefined where you can type it here. Okay, so I can basically type TCP, for example, TCP flags dot send and equal 1. That's mean is enabled. Okay. So if you don't memorize, no need to memorize these filters. So what you can do, for example, if you want to filter in certain type of the flags, what you can do is to select TCP and okay, goes down here and search for the flags. Okay, this is the flags, and you can see here the flag is SYN. SYN is set. So if you want to use or filter the traffic based on TCP sync website, we can right click here and we can apply as filter and select it. So it will put this filter here. Or if you want to filter the traffic based on the TCP, can click on TCP and apply the filter selected, so it will list TCP. I think there is no need to, memorize. Just you can scroll here and see whatever columns you want to find it here, and you right click on this features and set it as a filter. So this is traffic that represent the TCP sync flooding attacks. So what we can do here inside, inside the dataset, there is a dataset description Excel sheet. You can open it. Okay. So the Excel sheet. Okay, this is the Excel sheet where you can find what are the filter for the attacks. For example, we are searching for TCP flooding attack or DDoS sync flooding attack. Okay, this one. We can see this one. And here we can find a filter here. Right here we can find the filter. Okay, so we copy that filter and we scroll. We open back this. Okay, so we can see that these destinations, so this destination IP address, okay, on this certain port number, receiving a lot of sync, right? A lot of sync, TCP sync buckets. Okay, so we have a lot here. Okay, so that's mean this attack is, okay, maybe this is a glue that's this destination, okay, under TCP sync flooding attacks, because it has a lot of flags on the a lot of TCP sync based on this flag number. Okay, so you can add this one to study the behavior of the attacks. Okay, so this is one command. Another thing that I have done is to write a simple Python script just to read this. Okay, just to read this pcap file, and here we are, reading, filtering based on TCP, and here we are also, okay, reading the TCP sync flag, and we are counting the number, okay, of packet received by each destination, and this packet designed or target certain destination port. So for each destination, we want to count the number of packets that received on specific destination port. Okay, so this is a script that, okay, just we want to see the abnormality on these destinations. So this destination compared to other destination, how many TCP sync packets received. Okay, so the result will be looked here in output.txt, and this is finished. We can see open the output, and we can go here, search for that's IP address. Okay, so here we have, see, this is the destination that we are looking for. If you notice, this destination is 13. Okay, this is the same destinations and the same port that we put it in Wireshark, and it received 16,866 TCP sync. Compared to others destination which is received 1 or 2, okay, that means there is abnormality, because in the same duration I'm receiving a lot of TCP sync flooding, TCP sync flags compared to others, okay, the host. That means based on this data, I can, I can say that there is abnormal activity. Okay, so we need to take further step to confirm whether this scan or whether this TCP thing flooding attacks is it triggered from Mirai or not. And what I'm saying, we have to take a further step, because maybe the TCP thing flooding attack is not triggered from Mirai. Maybe it's triggered from non-Mirai malicious code. Okay. So, but the most important thing, you will be able to identify it using very simple filtrations command in Wireshark, for example. Okay, so this is for the first like attack. Okay, so we also have in the file, we also have TCP like UDP, the Mirai UDP flooding attacks. Okay, and again, we can go back to, so this is clear. Okay, and this time for UDP. Okay, again, we can refer to the Excel sheet here, search for UDP. Okay, and we are using UDP, this file, and again, okay, there is a command line here. Okay, we can copy this one and this one. So we are not really care about the command line. Rather, we want to see what are the symptoms, what are the behavior of this attack. When we talk about UDP, what we will get when we apply this filter. So if we implement this one, click apply for filter. Okay, what we can get here. Okay, so so this is no longer needed because it's, you know, we can TCP flags. We are talking about UDP. And okay, so here is the UDP. So when we see this traffic, what is really interesting here is two things. The first one, and these two things align with the TCP UDP flooding attacks. First things, you know, it's all have the same packet size, 18, 18, 18, right? So normal user will not sending the same packet size. For example, if you wanna open any website, so the index page will have certain packet size. Okay, when you go to the sub pages, it will have different, you know, the different packet size. So there is a variations in the length of the packet size. But here all same. That means it's triggered from bot or from a robot, not from human. Okay, this is the first symptoms. The second one is also, I can see that there is a sequential scanning here. So 84, 85, 86, 87, 85 again. So there is a sequential scanning. Again, this is contradicting with the normal behavior. So these two symptoms, okay, confirm that there is a UDP flooding attacks in the website. Okay, so this is also small bucket size, usually used by flooding attacks. You know, use small size is to speed up the process, the propagation process. Okay, they will not use huge bucket size. So you use small bucket size along with, you know, difference source. Okay, source ports. So again, here is the filter. If you don't know, let's say, if let's say apply here, and we want to go down here to UDP, and we want to filter based on the source port, we can filter based on the source port. But if you want to for internet protocol certain destination, we can also implement the filter here. Right click, also apply as a filter, and selected. So this is IP dot destination, and it will give you the destination port. So this is the second type of the attacks. So first we talk about TCP string flooding attack, and second we talk about UDP flooding attacks. So what about let's say brute force attack? Okay, close it. Okay, so here we want to filter based on TCP dot source port equal 23, and this is the telnet in. Okay, so this is the telnet in OK port. So here we are talking about the brute force attack. That's mean you are guessing the username and password. Okay, so as you can see here, when we type, so we can type TCP source port equal 23, or we can straight type telnet in. So what we are testing here in the telnet in data. Okay, so here we have like example. Okay, so here we have the first one. If we click on here and try to do follow TCP stream, you can see here there are guessing. You see root, this is the password. Root, okay, invalid login name, okay, and this is the console of the attacker, for example. So try to first one, the second one is based on the dictionaries. So always we will get a lot of invalid login, and always we get a lot of, an attempt to bear username and password. And this is also the way that the brute force attack is working on. So it's keep on comparing, or the username and password that's saved in the predefined data sets, and the username and password that it's key in the console of the console to access the telnet in, that is running on the victim device. So this is again this is a brute force attack. So here we can also apply this on the stream, or we can take the commands from the Excel sheet and we can apply it here on the filter. So this is the three tabs that we want to looking on it. The fourth one and the last one is, okay, and it's a very important thing, is how we can, identify whether there is a scanning or not. So let's briefly talk about TCP and UDP scanning. So usually when we have a host, so this host will be active or inactive, and of course will be ideal. So let's say we talk about active and inactive. If we are, trying to do like random TCP and UDP scanning, and when we talk about random, that's mean blind scanning. I don't have any prior knowledge about the host that is currently active. I don't have any knowledge about the victim networks. So that's mean the probability of having or targeting inactive host, or means host is already shut it down, very high. So when I send TCP or UDP to inactive device, I will get an ICMP destination unreachable. But if I'm targeting active host, and in this active host, I have active and inactive services. So we are looking here, okay, we are looking to inactive service. If we are performing UDP sequential or random scanning, and we are targeting active host but inactive service, like for example in our scenario here, we have a Mirai a botnet try to scan an IoT device, but this IoT device is up, it's running, okay, but the telnet is not installed. The telnet port is closed, okay. So what I will get, if I'm performing TCP, I will get TCP reset message, a lot of TCP reset message. That's mean there is a TCP scanning on inactive port. But if I perform UDP scanning on active host, but the service that I'm looking for it is inactive, I will get a lot of ICMP port unreachable, Internet Common Message Protocol. And as we know, this messages is used for troubleshoot, and it gives you knowledge about, also some knowledge about the services and host that is running. So this is the assumptions that we are rely on to, let's say, to detect if there is scanning or not. And as I mentioned earlier, scanning activity is shared with a lot of malicious codes. So it's common between a lot of malicious codes. For example, when we talk about network worm, the first step is to perform network scanning. When we talk about Mirai, same. The first step is to perform network scanning. But the other type of botnets also perform of the network scanning. So having the network scanning undefined at the early stage, it can be lead to detect different type of attacks besides Mirai botnets. So we have to give a close eye on these three types of messages. The first one is ICMP destination unreachable. Second one is TCP reset message. And the last one is ICMP port unreachable. So let's see our assumption is valid or not by using the datasets that we have downloaded. Okay. So in that datasets, we have also a lot of traffic related to the scan. So you can pick up, like here, we have Mirai's host. If we search here on the scan, so we can find host port. Okay, all of this is scan. Host port or port, all the traffic. So we have a lot, maybe around 10 pickup files relating to the scanning, host and service port. So each service has a port. So when we search for do scanning for the port, as I mentioned earlier, we'll get a certain type of the messages. So let's jump into the pickup file again and see what we will get here. So we have here we have used I have used the scan port host 6. Okay, so double click, it will open. And here what we are interested in is to search based on ICMP. And you see here is ICMP port unreachable. We have a lot of ICMP port unreachable, ICMP port unreachables. And this port unreachable, as I mentioned earlier, okay, if we go, let's say we close this one and we go here. And you see here is a UDP, is a response for a UDP message. Okay, so ICMP port unreachable is a response for UDP datagrams. Okay, so that's mean when a UDP packet send or scan inactive service, I will get ICMP host unreachable. And this is host unreachable is an ICMP type 3 code 3. Okay, so type 3 code 3. That's mean I can filter exactly for this message if type equal 3 and ICMP dot code equal 3, and I can filter out. Okay, and I will get all. So this is again how to get. Okay, so this is again how to get the ICMP port unreachable. Okay, so this is a result of maybe a UDP scanning that's like targeting inactive port. Okay, so what about if TCP buckets targeting a host which is active but the service is inactive? As I mentioned earlier, we'll get TCP flags, and here we are looking for reset packets number 1. And let's see whether we'll get a lot also. Okay, so again, this is for okay TCP flags dot reset back equal 1. So here again there is maybe this is a symptoms of the presence of TCP sequential or random scanning. Okay, so but as you notice here, we don't have this type of okay ICMP destination port destination unreachable, or rather we got ICMP port unreachable. This may be because the attackers have a prior knowledge about the networks. So I know that the device is active, is up, so I can scan it. Okay, but if I blindly scan host, so the possibility of targeting or sending a packet to any active host will be high, and which is resulted to ICMP destination host unreachable. But in this case, we don't have this type of messages, ICMP. So we only have ICMP port unreachable type 3 code 3. Okay, we don't have host unreachable. And again, here is for UDP and TCP reset for the TCP. So, and this is the one of the DDoS attacks that is, listed here. So we have UDP, we have TCP single failing attacks, we have plain UDP, TCP storms. So there are a lot of the attacks that you can explore, okay? And all of these attacks, as I mentioned earlier, from the source code of the Mirai botnet. So the dataset, the link for the datasets is already here. So you can download this dataset and you can explore it. You can explore it and, and do more hands-on. Okay, with that, I conclude my presentation for the day. Thank you for your attention.